A very good morning to all of you.
Good morning,
Good
ma'am.
morning.
Good morning, ma'am.
Good morning, ma'am.
Good morning, ma'am.
Good morning. Yeah, so today we'll discuss the last topic of Unit 2, means last from the first part. There are two parts, I have told you already that there are two parts in Unit 2. One is fuel and combustion, and the other part is cement. So we were doing fuel and combustion. So in fuel and combustion, we have seen what is fuel, what are the different types of fuel, what is calorific value, what are the different types of calorific value, what are the different units of calorific value, and how one unit can be converted into the other unit. These things we have seen. After this, we have seen the determination of calorific value, gross calorific value by Bohm calorimeter. Then we have seen carbonization of coal. Carbonization, the method to convert coal into coke. This thing also we have seen. Then analysis of fuel, proximate and ultimate analysis, which determines the quality of fuel, that we have seen, proximate and ultimate analysis. Now, the last topic of the first part of the second unit, that is flue gas analysis. Flue gas analysis. So today we are going to discuss flue gas analysis. Please wait a minute. Let me share the slides. Yes, yes. Is the slide visible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So flue gas analysis. First of all, you must know what is flue gas, and when you know the composition of the flue gas, how these gases are analyzed, how these gases are determined in a particular fuel. So whenever a fuel burns, there is a mixture of gases which comes out from the furnace. Whenever we burn any fuel in a furnace, then it, in addition to the residue which remains in the furnace, there are certain gases which evolve out. So those gases are those, that is a mixture of gas. It contains a large number of means some more amount of carbon dioxide, carbon monoxide, oxygen, plus some amount of nitrogen is also there. So though that is a mixture of gas which comes out from the furnace, and that mixture of gas is only called as flue gas. The major composition of flue gas is carbon dioxide, carbon monoxide, and oxygen. So this can be asked in MCQ, the composition of flue gas, carbon dioxide, carbon monoxide, and oxygen. So if our fuel is of a high quality, having a high calorific value, then it mostly produce carbon dioxide because it will burn completely, and you all know that complete combustion of any hydrocarbon results in the production of carbon dioxide. But if the quality of our fuel is not good, in that case, it is not going to burn completely. And in that case, the amount of carbon monoxide, the poisonous gas, due to incomplete combustion, it is going to get liberated. Okay, so if we know the composition of the gas coming out from the furnace, we will be able to know the quality of our fuel. Okay, so complete combustion will always result in carbon dioxide. Incomplete combustion will always result in the production of carbon monoxide. So the mixture of gas, which is analyzed, mixture of gas coming out from the furnace, when we analyze those gases, that is going to give us the quality of our fuel or the combustion efficiency of our internal combustion engine. Okay, it is going to give us efficiency of combustion. Till now, any problem?
No.
Okay. So for the analysis of flue gas, we use Offset gas analyzer. Offset gas analyzer. So what is offset gas analyzer? It is an equipment which is used to analyze a mixture of gas. Basically, it is used, especially it is used for the purpose of analyzing flue gas. Okay, whenever any fuel is burnt. So it consists of a water jacket, as you can see. It consists of a water jacket, as you can see here in the diagram. Is it visible?
Yes, visible, ma'am.
Yes, ma'am.
Okay. So offset gas analyzer consists of a water jacket, which is this water jacket contains a graduated pipette, and this graduated pipette is connected with the water reservoir. From water reservoir, the water reservoir is provided with a rubber tubing, which is connected to the pipette, which is connected to the graduated burette. Now you all know that burette is having from the burette we can take the reading up to 0.1 ml. Okay, so what we do is, what is done here is, water jacket is there. This water jacket surrounds a graduated burette. This water jacket surrounds the graduated burette, which is connected with a water reservoir by a rubber tubing. Then this graduated burette is connected with three different, as you can see here, it is connected with three different burettes, three more burettes. They can be called as absorption bulbs. There is one graduated burette, and then it is connected to three different burettes, three different pipettes. Okay, one is in the first pipette, KOH is there. In the second pipette, pyrogallic acid is there, and in the third pipette, cuprous chloride, anhydrous cuprous chloride is there. Okay, anhydrous cuprous chloride is there. Then it is connected with another. These three burettes have stopcocks present in the top, which can be closed and opened according to our requirement. These can be closed and opened. The combination of these three pipettes, they can also be called as absorption bulbs, because they are mainly used for the absorption of gases. They are mainly used for the absorption of gases. Now, these absorption bulbs are connected into a glass tube, U-shaped glass tube, which has solid fused calcium chloride present in it, such that this fused calcium chloride is present, means on both the sides of the U tube, it is present equally. And from the top, it is also covered with glass wool, so that no unwanted air can go into it. Now, is the diagram clear to you?
Yes, ma'am.
Okay. Now, what we do is, okay, let me explain the diagram only. It is not given separately. Yeah. So what we do first is we allow the flue gas. See, everywhere there is a stopcock. Everywhere there is a stopcock. After the fused calcium chloride tube also there is a stopcock. We can open it. Then there are 3 stopcocks present here in the burette, in each and every pipette. As you can see here, 1, 2, and 3. These stopcocks also can be opened and closed according to our requirement. Okay, so what we do is, first of all, we pass flue gas into this Orsett gas analyzer. From where? From one side of the U-tube. From one side of the U-tube, we pass flue gas into our Orsett gas analyzer. In U-tube, what is there? Fused calcium chloride. Okay, fused calcium chloride is there. So what is the function of calcium chloride?
Absorbs water.
Yes, it traps water. Whatever moisture, water vapor is there, that is trapped by calcium chloride, and the flue gas becomes dry. Other than water vapor, it is not going to absorb anything else. It is not going to absorb any other gas, because it's a specific property of calcium chloride to absorb moisture. So it first our flue gas is passed through calcium chloride tube, which absorbs moisture. Then our flue gas becomes dry, and then this dry flue gas is allowed to pass into the first pipette, that is potassium hydroxide pipette. It is allowed to pass into the first pipette, which contains potassium hydroxide. So for this, what we have to do? We have to open the first stopcock, which is connected to the U-tube, and we have to open the KOH stopcock, which is connected to the KOH pipette. So these two only first we will open, and we will allow our flue gas to pass into the first pipette. Got it?
Yes,
Now,
ma'am.
now what is done? This KOH has the specific property to absorb carbon dioxide gas. So it will absorb carbon dioxide. All the carbon dioxide which is there in our flue gas will be absorbed by KOH. And then the remaining gases, here there is one more opening through which we can pass the the burette which is connected here. Here the burette which is connected is mainly used, this burette is mainly used to pass the remaining gases back into the U-tube. Okay, because it is going to cool the gases. So first of all, the gas is passed through the KOH pipette. KOH is going to absorb all the carbon dioxide. Now what else is left? Carbon monoxide and oxygen is left. So the remaining gas is passed into this burette. It will pass into the burette and it will get cooled. Now these cold gases are allowed to pass. Now what we'll do, we will not allow these gases to pass into the burette completely. What we will do, with the help of water reservoir and rubber tubing, it is provided with rubber tubing and water reservoir for this purpose only. After the complete absorption, what we will do, we will close the first stopcock, that is, which is connected to the KOH. Now remaining gases are there. So what we will do, with the help of water reservoir, we will introduce some amount of water into the burette so that the gases will cool down. Okay, so the gases will cool down and will not enter, will not, there should be no space in the burette into which the gases can move. Getting it or not?
Yes, ma'am. Good.
Okay. Now this cold, what we will do, these cold gases are then allowed to pass into the second pipette, which contains pyrogallic acid. Pyrogallic acid has the property to absorb oxygen as well as carbon dioxide. But carbon dioxide is already absorbed by KOH pipette, so now only oxygen is left. So pyrogallic acid is going to absorb oxygen, all the oxygen which is present in our flue gas. Now again, after the absorption of oxygen by pyrogallic acid, remaining gas contains what?
Carbon monoxide.
Carbon monoxide. Yes, carbon monoxide, CO2 nahi, carbon monoxide. So now what we'll do, we will close our second stopcock also, and we will allow the gas to pass into the third pipette, which contains cuprous chloride. Cuprous chloride is going to absorb carbon monoxide. Okay. So for this purpose, we use anhydrous cuprous chloride or ammoniacal cuprous chloride, but cuprous chloride has the property to absorb carbon monoxide. It is going to give different reactions with carbon monoxide. So this cuprous chloride is going to absorb carbon monoxide. However, it has the tendency to absorb all the three gases, carbon monoxide, oxygen and carbon dioxide. But here it is going to absorb only carbon monoxide because already carbon dioxide has been absorbed by KOH pipette. Oxygen has been absorbed by pyrogallic acid pipette. So here it is going to absorb only carbon monoxide. Now, always we should see that the sequence KOH, pyrogallic acid and cuprous chloride, this sequence should be maintained. It cannot be reversed. The sequence cannot be reversed. Why it cannot be reversed?
Ma'am, cuprous chloride will absorb all three of them, and we can't identify how much content of present of each.
Yes, ma'am. True.
Good. So this is the reason we cannot reverse the direction because cuprous chloride is going to absorb all the three gases and we will not be able to identify the individual gases. So for this purpose, the sequence should be maintained. KOH, pyrogallic acid and cuprous chloride. Now, how to find the amount of carbon dioxide, amount of oxygen and amount of carbon monoxide? How we can find? We have taken a desired amount of, we have taken a known amount of KOH in our pipette. So first of all, we will measure the weight of the pipette, okay, and then we fill KOH into it. Again, we measure the weight of KOH, the weight of the pipette having KOH. Initial weight, similarly, initial weight of pyrogallic acid pipette, similarly, initial weight of cuprous chloride pipette. And after the absorption of gases, their weight are going to increase. So this increase in weight will be the weight of carbon dioxide, carbon monoxide and oxygen. Okay. So in this way, we can find the weight of carbon dioxide or carbon monoxide or oxygen present in our fuel. These are the chemical reactions which takes place. So first of all, flue gas is passed into caustic potash, that is KOH. Here it forms K2CO3 plus H2O. Okay. Then it is passed through pyrogallic acid. Pyrogallic acid is C6H3OH whole thrice. So what we have taken, alkaline pyrogallic acid, that is why it is written here alkaline KOH. Okay. So alkaline pyrogallic acid will absorb oxygen and it will form potassium salt of pyrogallic acid. Potassium salt of pyrogallic acid. So initially the pyrogallic acid is generally colorless, but its colors change after the absorption of oxygen due to oxidation. Then finally the gas is passed through cuprous chloride. With cuprous chloride, it forms a coordination complex. Okay, it forms a coordination complex with carbon monoxide. So this is how the chemical reactions takes place. Then working, the same thing, working already I have explained. Any doubt?
No, ma'am.
No, ma'am.
No, ma'am.
Okay. So this is mostly asked. Torsat gas analyzer can be asked in end semester exam also. If it is asked in end semester exam, then first of all you will have to explain about flue gas. What is flue gas? What are the components of flue gas? Then what is the need for the determination of the components of flue gas? About this you will give an introduction. Then you will make the diagram. After diagram, you will explain the whole structure. Diagram means whole diagram you will explain, and then working. After working, principle. Principle is simply the absorption of gases, by different components. So the principle. After principle, explain the equations. Okay, and then measurement, how you measure the amount of different gases. That much only. Tell me if you have any doubt, anyone is having any doubt.
मैम
हम्म
डायग्राम में जो वेपर आएगा ना, ये मतलब वो कहाँ पर जाएगा? पहले पिवट 1, पिवट 2, पिवट 3 पे जाएगा या ब्यूरेट पे जाएगा?
वाटर वेपर जो रहेगी वो तो एब्सॉर्ब हो जाएगी पहले ही।
हाँ जी मैम।
यू ट्यूब जो है कैल्शियम क्लोराइड है ना, उसमें
हाँ।
एब्सॉर्ब हो जाएगी। देन ड्राई गैस जो है वो ही सिर्फ जाएगा पिपेट 1 में पहले। क्यों? क्योंकि हम पिपेट 1 को पहले ओपन करेंगे।
मैम फिर तो वो वाला भी ओपन है ना, वो क्या बोलते हैं, वाटर वो वाला भी ओपन है ना, वहां पर
वही
भी
तो
जा
बता रही हूँ, वही तो बता रही हूँ। वो जो रिजर्वायर है, रिजर्वायर इज प्रोवाइडेड विथ अ रबर ट्यूबिंग। वहां से हम जैसे ही गैस पास करेंगे तो हम उसका वहां से जैसे हम पंपिंग करते हैं जिस तरह से, वैसे ही रिजर्वायर से हम ब्यूरेट में पानी डाल देंगे। ब्यूरेट फिल हो जाएगा, है ना। जब ब्यूरेट पानी से फिल हो जाएगा, वाटर से फिल हो जाएगा, तो वहां पे गैस कैसे जाएगी? नहीं जा पाएगी।
ओके मैम, अंडरस्टूड मैम।
है ना। So we every time when we open the stopcock of any pipette, first we introduce water from the reservoir into the burette.
यस
Got?
मैम।
Okay, so today I will share the slides of this, and next time we will start our cement. I will share the numericals based on combustion also. Please go through it. And if you find any problem anywhere, these are the solved numericals. Already we have solved. So if you find any problem anywhere, you can ask. Let me take attendance. Yes, now you all can leave.
Thank you, ma'am.
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 Thank you, ma'am.